All right, so moving on to lecture 8, profit maximization and firm supply. For this lecture, I just want to give you a heads up that I'm going to skip the long run firm supply problems. So these are the problems on pages 4 through 7. This is mostly just because I lost some, we lost 2 weeks of time, so I'm trying to cut a little bit of material out of the lecture, and I think this is sort of less interesting and less important, and the problems are a little bit convoluted, and I don't think it's sort of worth our, it's some of this, I think, lower value stuff that's remaining in the class. So anyway, without further ado, let's talk about firm supply. So for this class, what we're going to assume that firms do, and this is an assumption, but probably a reasonable one, is that firms maximize profits. All right, and that's going to be the standing assumption for this class. And we're going to denote profits with lowercase pi. So we're going to do this, or we're going to think about firms in lots of different market structures. So perfect competition, monopoly, oligopoly. For now, and basically before the second midterm, we are going to focus on perfect competition. All right, and so let me, and after the midterm, it'll be, monopoly and oligopoly models, but for now, just perfect competition. So let's talk quickly about what it means for a firm to be perfectly competitive before then getting back, or for an industry to be perfectly competitive before getting back and talking about how we use profit maximization in order to think about firm supply. All right, so there are 3 conditions that we assume are necessary for perfect competition. So the first condition is something we're going to call product homogeneity. All right, and what this means is that all products are very similar to each other. All right, and usually these types of products are then are referred to as commodities. So like one example of a commodity that we hear a lot about is like oil or gasoline, right? If you just like turn on the news, right, we'll think of, that's, if you read about like a commodities market, though, they trade like corn or oil or grain or other very similar products, right? And we refer to them as commodities. What does it mean, right? What's the implication of product homogeneity? Well, it means that if you are selling homogeneous products, you can't sell it at a higher price than the price that somebody else is selling it for, right? So if you're at a farmer's market selling corn, and the guy, the stall next to you is also selling corn, right? You can't charge a higher price, because if you did, everyone would just go next door, right? Because they're the same product, right? So there's no reason that you should be able to get a higher price, which is why there's one market price for these things, right? Which is why we can sell them on exchanges, right? Rather than like everybody knows, what the price of corn is, or what the price of oil futures are, because we know exactly what that product means. So what that in sort of more rigorous terms means, and this is a little bit technical, but what it implies is that firms face infinitely elastic demand. So I'm going to come back to this point a number of times because I think it's a really important one, but it's also a complicated one. The demand curve in the market, or consumers' demand, does not have to be inelastic, but the firm itself is facing infinitely elastic demand. If you're selling corn and your neighbor at a market is also selling corn, right? If you raise your price by 1 cent, all of your consumers should leave because you're selling the same product, right? Hence, as a firm, right, raising price by 1 cent, all quantity leaves. The demand that you face is infinitely elastic, even if the demand in the market for corn is not infinitely elastic. So that's what product homogeneity is going to imply. The second condition that we're going to need for perfect competition is price taking. And this just means that consumers firms take prices as given. Right, so there's one market price and firms have no ability to change that market price, right? So if, one example I think of being a price taker is like when you go to the store, right? The store just says, this is the price. Or if you go to Kroger, it says, it's $1.99 for a gallon of milk, or $3 for a gallon of milk, and you have no choice. Situations where firms are not price takers. So if you, in the news right now, there's this oil war between Saudi Arabia and Russia, and those countries are trying to decide what the price of oil should be. So those are not, the firms, in OPEC, right, are not price takers. They have a lot of leeway to change prices. What situations do we often see price taking, or what do we sort of need for price taking to happen? Well, often to have price taking behavior, we need firms to be small relative to demand. Right, it's easier to influence prices if you control a large part of the market. But if you only control a small part of the market, you sort of have to take prices as given, right? This is why as consumers, right, because so many people are going to Kroger every day, right, to buy milk, right, we can't like bargain with them over prices. We just aren't important enough to do that. And then the final condition for perfect competition is free entry and exit of firms. All right, and what this says is that basically there are no special costs that make it difficult for a new firm to enter the industry. Or say government regulation. So cases where this is violated, so if you think about, say, like airplane manufacturing, right, there are only a few companies that do that, right? Boeing, Lockheed, Airbus, right? And the reason being, right, it's very, very expensive to set up new factories or get the skills needed to actually produce new airplanes, right? And so it's difficult for new firms to enter, right? But what this means, right, is that those firms can make outsized profits, right, in the long run. Right? If it was easy to enter, right, and firms could make very high profit, right, firms would just enter and compete that profit away. Okay, but when there's no free entry, say, if there are startup costs that are high, another example is patents. So like drug companies get patents for their drugs, right, which makes it so that other companies can't come in and compete down the prices. And so they, again, right, there's no free entry. And the reason that we do that, and I'll talk about this later in the class, is that it makes it harder for other firms to come in and compete, which gives an incentive for these firms to produce, to do research, right? But because of that, these firms are able to make outsized profits, and that's something that we don't normally see in perfect competition. So these are the three conditions that are necessary for us to have perfect competition. All right, so I want to take a little bit of a detour here and review first order conditions. The rest of this class is basically going to be, we're going to write down a profit function and then take a first order condition. So we spent a lot of time doing like constrained optimization problems. And not a lot of time doing unconstrained optimization problems. But I did talk about this in the math notes, and so you might want to go back and review those, but I'm going to do that sort of briefly in this lecture, just so that we all remember what a first order condition is, because we haven't done one for a while, and it's going to be important, and it's really important for me that we understand sort of the math that we're doing and why we're doing, taking derivatives and what that's doing. So again, right, we're going to be doing a lot of we will be taking a lot of first order conditions of profit functions. Or of profit functions going forward. And so that's really the goal for today, is like what does this mean again? All right, so I want to just go back to sort of where we started, right? Which is what we're trying to do, right, with a profit function is find like what's the profit maximizing price or what's the profit maximizing quantity. All right, so what we want really is what is that maximum, right? How do we find a local max? And so just to remind everybody, we have this definition of a local max. So a local maximum is a point where if you were to draw a circle around it, it would be the highest point in that circle. So a local maximum is a point where if you were to draw a circle around it, it would be the highest point in that circle. Okay, so just to remind everyone, the picture that I made you memorize at some point, we had a function. I'm going to go back to f and x notation, right? But we could also think of this as, say, pi and quantity. All right, so I'm going to explicitly use f of x here, but we could also think of this as pi of q, right? And x, okay? and we have a function, right? And let's say there are 3 points, B, A, and C. All right. And so the thing that we want to figure out is, well, which one of these is a local maximum, right? And so, like, if we say draw a small circle around B, right, we can see pretty quickly, right, it's not a local maximum because there are points, right, that are higher than it in this circle, right? Same with C, right? There are points higher than C in this circle, right? And so C is not a local maximum, but A, right, is. There's no points in this circle that are higher than A, okay? And when I say a small circle, I mean sort of, you know, this is not necessarily very small, but if we were to say take a derivative or get the circle smaller and smaller in the limit, right, it would be sort of the highest point regardless of how small that circle gets. So what is it about A that's different than B and C? Right? Or what's the thing that I wanted us to memorize? Right? Well, the thing that's special about A, right, is that the derivative or the function is flat at point A. Right, or, you know, the function is flat at A, or the derivative is equal to 0, right? That's just another way of saying the function is flat, right? The derivative tells us the slope of the function, right? The slope is 0, meaning the function is flat, right? So why must the derivative be equal to 0, right? Why is that a good condition for maximization? All right, so let's look at like point B, right? So at point B, right, the derivative is positive, right? Or basically any point to the left of point A, the derivative is positive, right? Which means that if we increase x a little bit, right, because the derivative is positive, right, that means that the function value is getting larger, right? So because at point B, right, f prime of x is greater than 0, the derivative is positive, right, the function value gets larger if we move to the right. Right, so it's not a local minimum, okay? Same thing with point C, right? Anything to the right of point A, the derivative is negative, right? And so what that says, or what that means, is that if we move a little bit to the left, right, f of x gets bigger, right? And so it's not a local minimum, right? Only at point A, right, we can move either left or right, and the f of x does not get bigger. The function value does not get bigger. Right, why is that? Right, well, if we move a little bit to the left, right, the derivative is positive, but we're making x smaller, and so the function value gets smaller. If we move a little bit to the right, right, the derivative is now negative, right, the function value is x gets bigger, the function value gets smaller again, right? It's because the function goes from positive to negative, right, that on either side of the point A, right, the derivative, the function value gets smaller, right, when x gets, when we move further from point A, right? So on either side, right, going a little bit this way, the function gets smaller, or a little bit this way, the function gets smaller, which means that A must be a local max, right? But that's sort of the intuition, right, for why it must be the case that when the why we need the derivative to be 0, right, for this to be a local max. Now, in the math notes, I talk a lot about, what happens when we have a local min rather than a local max. I'm not going to worry about that as much here because at the moment we're thinking about profit maximization, and so we're just going to assume that we have functions that look like this and not the other way around. But so for now, right, we're going to be taking a lot of derivatives and setting them equal to 0, which is going to be called doing a first order test, right, because of this logic. So let me just sort of write that part down, right? So to find a local max, what we're going to do is take a first order condition. I guess usually we call this a first order test or taking a first order condition, which we're going to abbreviate with the letters FOC, okay? And what this is just step 1, like of a recipe here, is just take the derivative Step 2, set the derivative equal to 0. Right? So we're going to take the derivative of this function, we're going to set it equal to 0 so that we can find basically point A, and then we're going to solve for x so we know the x value at point A. And here I'm going to say, just to be consistent with the math notes, I'm going to say solve for x. Though if we're in a world where we're thinking of like pi of q, right, maybe what we want to do is actually solve for, q if that's what our function is. So let's do an example, but I'm going to do an example with pi's and q's just to make this a little bit more in the vein of what we're going to be doing in the next couple lectures. So let's say that we have a profit function, pi is a function of q, right, of quantity, profits is a function of quantity, where the profit function is 4q squared plus 4q. Okay, so what do we want to do? Well, let's just follow this recipe. So we're going to first take the first derivative. And that's going to be, so the derivative of this, right, is negative 8q plus 4, and then we're going to set it equal to 0. So that's basically steps 1 and 2. And then step 3, right, we're just going to solve for q. So let's add 8q to both sides, and we get 8q is equal to 4, or q is equal to 4 over 8, or 1/2. All right. So in the last lecture, we talked about conditions for perfect competition, and in the next lecture, we're going to talk specifically about how firms should produce or how much firms should supply under perfect competition, okay? But for right now, what I want to do is just talk about profit maximization more generally. And what I mean by more generally is under other conditions, not just perfect competition. So under monopoly or duopoly, like what I'm talking about now will always be true, okay? And again, the question that we're trying to answer at the moment is how much should a firm produce? How much output should a firm produce? And we're always going to do this under the assumption that firms profit maximize. Okay, and they do that by choosing Q. And we will, so I think this is something that I think a lot of students find a little bit odd. When we go to the grocery store, we go to the gas station, right, we see firms choosing prices, and so it's a little bit weird to think about firms choosing quantities. But for now, it's just going to make our lives a little bit easier as we'll move to a model of price setting near the end of the class, and we'll see that it raises a bunch of difficult issues. But in some ways, we can think about choosing quantity as similar to choosing price, depending on how big the market is. But we'll talk about that a lot more later. So what does it mean to maximize profits? Well, let's first write down the profit function. So profit, which we're going to denote with a pi, is equal to revenue minus costs. Right, just how much money is the firm taking in and how much money is it spending, right? The difference between that is profit, okay? So what are firms doing, right? Firms are choosing the Q, right, which maximizes their profit, okay? So how do we figure out, right, what's that optimal Q? And this is something that, like, for the rest of this class, is going to be really critical, because we're just going to do the same thing again and again and again, right? We're just going to write down the profit function. And take the first order condition. All right, every single time, we're just going to do this. And what's going to be changing as we change the market structure is how the revenue function works. That's it. So this, right, write down profit function, take first order condition. This is like, you don't even have to watch any of the rest of my lectures. It's really just this. If you can just remember to do this, you'll be good. So this is like, really, really key. So in general, right, regardless of market structure, the way that we do this, well, let's just take the first order condition, or to do that, let's take the derivative of the profit function, right? What does that look like, right? Well, that's just the derivative of the revenue function, right? Minus the derivative of the cost function because of the sum or difference rule that we talked about, in the first class. And because we're taking a first order condition, we're going to set that equal to 0. Okay, so what is this? Well, this first term, right, is just marginal revenue, right? Just the derivative of revenue with respect to quantity, right? So if we add one more unit of output, how much does revenue change? Minus marginal cost, right? We had that definition in our last set of lectures, right? But again, if you add one more unit of quantity, how much does cost change? Again, that's equal to 0, or just doing a little bit of algebra and adding marginal cost to both sides, right? We get marginal revenue is equal to marginal cost, right? You've seen this before, right? I assume in your principles class, like you've heard marginal revenue is equal to marginal cost, right? This is true no matter the market structure, okay? So this is marginal revenue equals marginal cost is the profit maximizing condition for any market structure. So, for monopoly, duopoly, perfect competition, etc. All right, this is always going to be true. Right? Why is that the case? Right? So suppose that the firm was selling at choosing a quantity so that marginal revenue is greater than marginal cost. Is the firm profit maximizing? Right? And the answer is no, right? Because if marginal revenue is greater than marginal cost, right, the firm should produce more output, right? It's making more money, right, on that last unit than the cost it takes to produce that last unit. Right? What if marginal revenue is less than marginal cost? Right? Is the firm profit maximizing? Right? And again, no, right? In this case, the firm should produce less. Right? Because that last unit that it's producing, right, costs more than the value that it gets. All right? So the takeaway here, right, is that regardless of market structure, it's going to have to be the case that in order for the firm to profit maximize, marginal revenue has to equal marginal cost. All right? So as we go forward, right, the thing that we're going to be doing in all of the later lectures when we think about monopoly, duopoly, perfect competition, is we're just going to think about, well, what does the revenue function look like in these markets, right? And that's going to tell us how to make this condition hold. But this is the condition we're always going to be working towards. So in the last video, I talked about profit maximization more generally. So in lots of different types of market structures, monopoly, perfect competition. In this video, I'm going to talk about profit maximization just under perfect competition, and then I'm going to discuss firm supply. So recall from the first video of this lecture that one assumption of perfect competition is price taking. So firms have to take prices as given. So like, there's just a market price for gas and or things at the grocery store or whatever. Firms are taking those prices as given under perfect competition. And what this implies is that the revenue function, right, or a firm's revenue is just equal to price times quantity. Okay? And I'll go into this a little bit more, but what this says is that firms cannot affect the market price. Right, they're price takers. So, okay, so this doesn't look like much, but let me give a little bit of a digression on sort of what this assumption is doing, or how this is an assumption. So this isn't for us yet, but I'm going to sort of foreshadow when we get to talking about monopoly, okay? And so under monopoly, the revenue function is going to look like this. It's going to be price as a function of quantity. Times the quantity sold, okay? So just to give a real world example of this, in one of the things that's in the news right now is this price war between Saudi Arabia and Russia. And the idea there, or what's happening there, I guess, is that Saudi Arabia would like to reduce the quantity of oil that they produce in order to sell it at higher prices. Russia seems to want to produce more oil in order to sell it at lower prices. And so they're fighting about how much quantity to produce, right? How much oil to drill, because that's going to change the market price, okay? So in that setting, right, where you just have a few firms, or in monopoly, maybe just one firm, right, firms can change the market price with the quantity that they produce, okay? In our assumptions about perfect competition, right, we're not allowing that to happen. The firm, there's just a market price, whatever the firm produces, it doesn't change the quantity, okay? So what does that then mean? So what we said, right, or our assumption is that firms are going to maximize profit. So under perfect competition, right, to maximize profit, right, firms are going to have the profit function, right, RQ, right, revenue minus costs, right? And we can, just like in the last video, we can take the first order condition, right? So let's find the profit maximizing quantity. All right, and so to do that, right, we're just going to take the derivative of profit with respect to Q, right, which is equal to the derivative of revenue with respect to Q minus costs, right, with respect to Q, right? Or, right, what we saw in the last lecture, right, marginal revenue, right, is equal, and because it's first order condition, we set it equal to 0, and so we get marginal revenue is equal to marginal cost, right, just by adding marginal cost to both sides, okay? So this was true generally. All right. But under perfect competition, marginal revenue is just equal to the price. Right? Because revenue is P times Q, right? Take the derivative of P times Q with respect to Q, and it's just P. All right? So what that tells us is that price is equal to marginal cost under perfect competition. Okay? So we have this general thing, marginal revenue is equal to marginal cost, that you've seen before. You've also probably seen before in your intro classes that price is equal to marginal cost under perfect competition. Both of these are true. Okay, so this is what profit maximization looks like under perfect competition. Now I'm going to transition to talking about what does firm supply look like. All right, and I'm gonna rip out this page, so if you want to pause the video for a second and write down things, I'm gonna give you just kind of a second to do that. Okay. So we know, or we just sort of derived, right, that a firm that's maximizing profit will produce such that price is equal to marginal cost. All right. But this is a little bit, like, even just saying this just in words is a little bit awkward, right? Because what I'm saying is the firm is going to produce this much output to make marginal cost equal to the price. Okay, so let me actually draw a picture here. So I'm graphing quantity and price like we would on, a supplier demand curve. And let's say that we have a marginal cost curve that looks something like this. All right, so we have, at some quantity, right, we can figure out what the marginal costs are, and, it's measured in maybe, dollars. Okay, and so what we're saying, right, is that if there's a given market price, let's just, this line here, right, we can figure out what the quantity that firm should produce is. Okay. So how do we figure out then, and for any price, right? So let's do this. Let's say for price, let's say for price 1, right, we can go over and we can figure out, okay, this is the quantity that the firm should produce. Let's call that Q1. For a different price, let's say this here is price 2. Right, we should go and we can figure out what the price is and what quantity the firm should produce, and let's call that Q2. Okay. So for any price, right, I can tell you what the profit maximizing quantity is. Right, or for any price, we can use the marginal cost curve to tell us the profit maximizing quantity. Okay, so what does this tell us though, right? So this is saying that for a given price, this is how much a firm should produce, right? For this price, this is how much a firm should produce. That sounds a lot like a supply curve, right? And so the idea, right, or what we want, right, a supply curve, and I'm actually gonna be really careful here and call this a firm supply curve, right? Because we're thinking of what an individual firm should produce, right? Is the quantity it should produce given a price. Right? That's what a firm supply curve is. It's just telling us the profit maximizing quantity for a given price. Well, how do we find that? Right? So I think people generally find this a little bit confusing, right? But what we do is we can just invert the marginal cost curve in order to get our supply curve. So I think students generally find this notation confusing, so don't worry too much about it. But I will explain it a little bit and then we'll go through a problem. You'll see it's really not that bad. This is just kind of strange. All right. So what I'm saying here, right, is we can just take this curve and invert it, which graphically doesn't actually look like anything. But what we're doing, so usually marginal cost is a function of Q, right? But what we're doing now is just saying, let's take for any price, we can figure out a quantity, right? When we were doing that, we were taking basically the inverse of the marginal cost curve, right? Usually the marginal cost curve, we're just saying, for the quantity 1, I can tell you what the marginal cost is, or for quantity 2, I can tell you what the marginal cost is, right? All I'm saying is, the exercise that we did a minute or two ago was actually this, right? We're taking the inverse of the marginal cost curve. And you're taking a price and just saying what the quantity is, okay? So I guess the thing that comes out of this then, right, is that the firm level supply curve is just the marginal cost curve. under perfect competition. Okay. So I find this a little bit confusing, and we'll go through this a little bit more, or we'll see this again. So don't worry too much about it. But just know that sort of we can use the marginal cost curve in order to trace out the supply curve, right? Because a firm supply, right, is a function of market price. For a given market price, we can figure out exactly what firm supply is, and that's going to look exactly like this marginal cost curve. Okay. So in practice, how do we find a supply curve? Right. Well, all we've done, right, is we've just figured out what is the profit maximizing Q. Okay. So we just have to do, we just have to write down. So we just have to basically maximize the profit function. All right. So to find the firm supply curve, we're just going to do the same thing that we did when we were maximizing profit. All right, and so the first thing that we should do, right, is just write down the profit function. And then take the first order condition in order to find the Q that maximizes profit. And then finally, we're just going to solve for Q. All right, so the example that I give in the notes, and I'm not going to worry too much right now about the fact that we can go from the production function to the cost function. I'm just going to start with the cost function to keep things easier. So the example in the notes, and here I'm skipping to about page 8. So I'm just doing the short run cost function, which is all you're going to be responsible for. I'm going to skip the long run problems because they're a little bit more complicated, and it's something that I don't think is super important. And given that we lost 2 weeks of lecture, I think it's probably one of the marginal topics. So we're just going to skip to page 8, short run cost function. You're not going to be responsible for the long run problems sort of in between all of this. But here, I give a cost function. So I call it SC for short run cost is equal to 125 plus Q squared over 20, right? And then the goal is let's find the firm supply function. All right. So how do we do that? Well, first let's write down the profit function. All right, profit is always revenue minus costs. All right, and with perfect competition, it is always P times Q, right? Under perfect competition, revenue is always P times Q. Minus cost, so minus 125 minus Q squared over 20. Okay, then what we're going to do is just take a first order condition. So that's going to be, so take the derivative of profit with respect to Q, that's going to equal P minus 0, right, minus 2Q over 20. And because this is a first order condition, we're going to set that equal to 0. All right, and then we're just going to solve for Q. So this is going to be P is equal to 2Q over 20, or Q is equal to 10P. Okay, so that's going to be our answer. This is, if the price is 2, the firm would produce 20. If the price was 3, the firm would produce 30. If the price was 4, the firm would produce 40, so on and so forth, right? So that's the firm supply curve. Okay. One other thing that I just want you to be aware of, right? If you write down marginal cost, right? Marginal cost here is 2Q over 20, right? Marginal cost, marginal revenue. So when we take the first order condition, right, we see in this step that marginal cost is equal to marginal revenue, or maybe this step here is easier to see that because I have the equal sign. All right. Right, so now we've gone through an example problem for how to find a short-run firm supply function. I have a handout, H08 profit max and firm supply, that I posted online. Now would be a good time to do that. And I'm just going to talk about the solutions to that handout. So you might want to work on that on your own for a little bit first. And then you can either look at the solutions online, or you can watch me talk through that. All right, so what we have in that handout is a cost function 1/3 Q cubed plus 50Q squared, just 50Q plus 2000. And the goal is to find the short run firm supply function. All right, so what do, right, to find a firm supply function? Well, the first thing that we're going to do is just write down the profit function. All right, profit is always revenue minus cost, always, always, always true. Okay, under perfect competition, right, revenue is just price times quantity, and then we're going to subtract off the cost, which is 1/3 Q cubed minus 50Q minus 2000. Okay, so this is just writing down the profit function, always P times Q for revenue under perfect competition. Okay, then we're going to take the first order condition. All right, and so that is, we'll take the derivative of the profit function with respect to Q. Okay, so the derivative of P times Q with respect to Q is just P. The derivative of 1/3 Q cubed with respect to Q is just Q squared, right, minus 50. And then this doesn't have a Q in it, so it's 0. And what we're going to get is, and then because this is a first order condition, we're trying to find the point where the profit function, the slope of the profit function is equal to 0. We're going to set this whole thing equal to 0. We're going to get this function here. All right. From there, right, we're just going to solve for Q. And so let's add Q squared to both sides. So we're going to get Q squared is equal to P minus 50, or Q is equal to the square root of P minus 50. Okay. And so this is our profit function, or sorry, this is the firm supply curve. right? So if the price was 50, the firm would produce nothing. If the price was 1, the firm would produce 1 unit. If the price was 51, the firm would produce 1 unit. If the price was 59, right, the firm would produce 3 units, so on and so forth. So I want to talk briefly about the idea of shutting down, which is something that I think it's a little bit technical, and so I'm not going to test you on the math part of this, but I do want you to understand the concept and sort of the conceptual idea of this, and you'll see sort of what I ask on the homework about this. And there's also just a very relevant lecture for right now. So there's this issue, right? We're thinking about the short-run production, and there's this issue of what happens when it's not profitable for the firm to produce. So let's say just that something happens where demand gets really small, right? What should the firm do? What should the firm do? Right, and the problem for the firm, right? If it's not selling anything, right? If you're Little Italy right now and you're not selling anything, right, the thing you would want to do is stop paying your mortgage and stop paying your workers because you aren't selling anything. You want to bring your cost to 0, right? The problem is that technically in the short run, and I'm just going to shorthand this with SR. So in the short run, right, capital is fixed, right? That's like the definition of what the short run is, right? Which means, right, that the firm still has to pay their fixed cost, right? Little Italy has signed the lease, right? They still need to pay the landholder for the space, right? Or they have to pay for their stoves or whatever other material that they've rented, right? Or the capital cost on the material that they own, right? So firms that produce 0 output, right, still have to pay fixed costs. In this case, that's going to be R times K naught in the short run, right? And so what this is, right? So if a firm produces 0 output because they have no workers, right? So Little Italy, is sitting there, empty store with no one working, right? We call this shutting down. All right, and the distinction here, right, is that in the long run, right, firms can exit. Right, which means they can close their doors permanently. They can leave. When they can get out of their lease, they can leave and let another firm come into that building or leave that area vacant. But basically, exiting means that they're able to get out of their fixed costs. Right, permanently. So that's sort of the distinction between shutting down and exiting. So when should a firm shut down? Right? When is that the thing that the firm should do? So should it shut down if it's not going to be profitable? Is that when a firm should shut down? And the answer is actually no, that's not right. A firm should shut down when its revenue is less than variable cost or the wage bill. Okay. And I'll talk about why this is in a moment and why you might have unprofitable firms that are still running. Just to clarify one thing, in the notes, sometimes I say that the shutdown condition is when price is less than average variable cost. Right, and these are actually the same condition, right? So average variable cost is just variable cost divided by Q. Price is just revenue divided by Q because we're in perfect competition, all right? So I'm just dividing by Q when you see this condition here. Okay, so why would a firm operate with negative profits? All right, and the reason is, right, that they can't get out of their fixed costs in either way, and so it may not matter that they're not profitable if their lack of profit is because of paying fixed costs. So let me give an example here. And just to sort of give the answer to the question that I posed, it's fixed costs are the answer. But let's say we have a firm that if it were to produce, would have revenue of 100. If it were to produce, its variable cost would be 50, and its fixed cost would be 200. Okay, so if the firm produces, what's its profit going to be? Right, well, its profit is going to be revenue minus costs, right, or 100 minus 50, right? It gets the revenue because it's producing, but it has to pay the wage bill because it's producing, minus its fixed costs, right? Which is going to be then negative 150, okay? So this firm is losing money, right, in this short period, right? But let's think about if the firm doesn't produce. All right, in that case, right, its revenue is 0 because it's not producing. Its variable cost is 0 again because it's not producing. And so its profit is just that it has to pay the fixed cost of 200. Okay, so this firm, right, is unprofitable in the short run, right? But it makes sense for it to still operate, right? Its variable cost is less than its revenue, right? Revenue is greater than variable cost, so it shouldn't shut down. It's making more money by producing than by shutting down, so it shouldn't do that. Okay, so what does this whole idea of shutdown then mean for our firm supply curve? Okay, so what this means, and this is, I think, very confusing to a lot of students, is that we should, so don't worry about this too much, but I just want to kind of go through the technical part of this. Is that we can rewrite the firm supply curve as a piecewise function, okay? So you'll see this in the notes. I'm not going to sort of require you to sort of understand the piecewise function here, like specifically, but I think it's intuitively, I want you to understand what's going on. So the firm supply, right, if the price is greater than average variable cost, right? So if they're getting more money by producing than not, or revenue is greater than average variable cost, like it is in this example, the firm should produce. How much should they produce? Well, they should produce the amount of their marginal cost curve, right? Like I said in the last video, the firm supply curve looks a lot like the marginal cost curve, right? However, right, if price is less than average variable cost, right, then the firm shouldn't produce at all, right? Because they're losing money by opening their doors, right? If their value is if their revenue is just not going to be big enough, if demand isn't high enough, right, they shouldn't be open. Okay. So I'm not going to test you on how to actually check for this, but I do this in both the notes and the handout. But just to kind of go through the point here, right, on the handout, in the handout, right, we had a supply function that was like Q is equal to 50 minus P. Okay. And if you went through and actually plugged through this, right, what you would find is, say, if the price, if the market price was 45, right, let's say, right, then this firm shouldn't produce, right? And you can go through and sort of check in that example, like what happens if the price is 45, what is the average variable cost, right? One sort of condition here, and this will get asked in the homework, right, then is if, the price is less than the minimum average variable cost, right, then the firm will never produce. So I don't want to use a new part of the paper, but remember we had, a variable cost curve, and we could have an average variable cost curve, and if it looks, say we have an average variable cost curve that looks something like this, right? If, there might be some, for like a price here, right, there's a quantity that the firm might, any quantity above this the firm might produce at, right? But if the cost gets too low, right, there's never a value in which the firm would want to produce. And so that gets asked in a question. But, more to the point, right, for any, the firm will never produce if if the price is less than basically the lowest average variable cost that the firm can achieve given how much capital they have in the short run.